Hello everyone, welcome to IZ Bits. We train and you learn. Today I am going to describe about another basic concept, friction, in Newton's law of motion. Please visit IZ Bits on YouTube, follow the link, subscribe, click on bell icon. You get notifications of videos as we upload videos on YouTube. Friction. When considering friction, friction is a force which always opposes. Friction is a relative motion between two surfaces in contact. Friction acts parallel to the surface and opposite to the direction of motion, and friction is a retarding force. Friction opposes motion, so the force of friction acting on an object is proportional to the normal force. Friction is often referred to as a retarding force because it opposes the motion of an object. When an object moves across the surface, the friction acts in an opposite direction to the object's motion and slowing it down or preventing it from moving together. Now look into types of friction, internal friction and external friction. Internal friction occurs within a material and also encountered within the mechanical components due to their internal structure. External friction. External friction occurs between two separate objects or surfaces that are in contact with each other, or a friction between moving parts. There are three types of external frictions: static friction, limiting friction, and kinetic friction. Static friction is a type of friction occurs when two surfaces are in contact but not moving relative to each other. The force of static friction prevents the object from starting to move. Now coming to kinetic friction. Kinetic friction occurs when two surfaces are in motion relative to each other. It acts to oppose the motion of the object and it is typically slightly weaker than static friction. Now limiting friction. This is also known as maximum static friction. Is the maximum amount of frictional force that can be exerted between two surfaces before one starts sliding relative to other. Once the force applied to overcome the static friction, when it exceeds the limiting friction, the object will begin to move. It is called limiting because it represents the upper boundary of static friction, beyond which the motion occurs. There is another friction, rolling friction. Rolling friction occurs when an object rolls over a surface. It is generally lower than the kinetic friction and static friction because the rolling motion reduces the amount of surface area in contact, decreasing the friction force. There are few more points. The static friction is always equal to applied force in magnitude. It is self-adjusting friction. The maximum value of static friction is also known as limiting friction. Kinetic friction is the frictional force prevent when body slides over the other. When applied force is slightly beyond the limiting friction, the motion of the body starts. And the kinetic friction is also known as dynamic friction. Here we have static frictional force or limiting frictional force is equal to the coefficient of static frictional force and normal force. Here mu k is less than mu s. The kinetic coefficient of kinetic friction force is less than the coefficient of static friction force. The limit is 0 is less than or equal to force of static frictional is less than or equal to limiting frictional force. When a block is resting on a surface, there is typically four forces acting on it. Weight. This force acts vertically downwards from the center of the mass of the block. It is the force exerted by the gravity on the block's mass, causing it to experience weight. And this is normal force. This force acts perpendicular to the surface of contact between the block and the surface of it's resting on. It counteracts the force of gravity and prevents the block from sinking it to the surface. The normal force is equal in magnitude but opposite in direction to the force of gravity when the block is at rest. And this is a frictional force. If the block is not sliding, there is a static friction acting between the block and the surface it's resting on. This force is acting parallel to the surface and opposes any tendency of the block to the slide. It rises due to the macroscopic interaction between the surface and contact. And there is another force, applied force. If an external force is applied to the block and perhaps by pushing or pulling it, this force would act in the direction of push or pull. It could be horizontal or vertical or at any angle depending on the circumstances. Here is the equation for normal force, N is equal to mg. The applied force at which is equals to the frictional force is static, which in turn mu as N is a normal force, is replaced with mg. The equation for F is ma, which in turn is equivalent to mu s mg. Mu s is the coefficient of static friction, is equal to, now by simplifying we get A by G. See, cancels and A is left and G is left in this side. We left with A by G for coefficient of static friction. Angle of response. The angle of response typically refers to the angle at which an object begins to slide when subjected to an inclined surface. When an object rests on an inclined plane, such as a ramp, the inclination of the surface is gradually increased. There comes a point where the static force can no longer support the component of the object's weight parallel to the surface. At this critical angle, which is known as angle of response or angle of friction, the object begins to slide down the incline. The angle of response depends upon the coefficient of static friction between the surface in contact. Higher the coefficients of friction results in steeper angles of response, meaning the object can be inclined more before sliding occurs. Understanding the angle of response is essential in various applications, such as determining the maximum slope a car can climb without slipping, or designing a stable structures on inclined surfaces. The angle of inclination of the plane with respect to the horizontal for which the body will be limited equilibrium on the inclined surface just begin to slide down. Look at this diagram. On the object, the block, we are seeing four forces: frictional force, normal force, weight, and applied force. As we see, normal force is equivalent to mg cos theta. The limiting frictional force is equal to mu s n. Limiting frictional force is equal to ms mg cos theta. And then now applied force mg sin theta is equal to ms mg cos theta. We replaced mg n with mg cos theta. Then us is equal to, by simplifying we get coefficient of static friction force is equal to tan theta. Identify frictions from graph. When plotting friction forces versus time for static and kinetic frictions, the graph would look like this. Static friction. Initially, the graph starts at zero friction force, indicating that object is at rest and experiencing static friction, which is holding it in place. When the external force is applied to overcome the static friction, The friction force gradually increases with applied force until it reaches the maximum static friction force. Once applied force exceeds the maximum static friction force, the object starts moving and the static friction force is overcome. At this point, the friction force drops suddenly to the lower kinetic friction value. The graph then shows the relatively constant friction force corresponding to kinetic friction as long as the object continues to move at the constant velocity. The kinetic friction, the graph starts with a sudden drop from the maximum static friction force to lower kinetic friction force once the motion begins. Unlike static friction, the kinetic friction remains relatively constant over time, as long as object continues to move at a constant velocity. If the object accelerates or decelerates, the kinetic friction force may change accordingly, but it generally remains constant under steady conditions. Look at the problem. A block of mass 4 kg is resting on the rough horizontal plane and is about to move when a horizontal force of 30 Newton is applied on it. Find total contact force. Given acceleration due to gravity g is equal to 10 meter per second square. To find total contact force acting on the block when horizontal force is applied to it, we need to consider the forces acting in the horizontal direction. Given data, mass is 4 kg, applied force is 30 newtons, acceleration due to gravity is 10 meters per second square. The friction force acting on the block before it starts to move, the maximum static friction force is given by mu s into n. Mu s is a coefficient of static friction between the block and surface. N is the normal force acting on the block. Since the block is at rest, the normal force is equal to magnitude but opposite direction to weight of the block, which is mg, with which we get 4 kg into 10 meter per second square is 40 newtons. The normal force we get is 40 newtons. We can calculate the maximum static friction force using a coefficient of static friction. However, since the block is about to move, the applied force is equal to maximum static friction force. So, F applied is equal to F friction maximum. 30 newtons is equal to mu s into 40. We get 0.75. The coefficient of static friction is 0.75. We have the coefficient of static friction. Now we calculate the total contact force when the block is about to move. Since the applied force is equal to maximum static friction force, the total contact force is sum of the applied force and normal force. So we add 13 newtons and 40 newtons, we get 17 newtons. The total contact force acting on the block is now 70 newtons. Thanks for watching. Please like, share, subscribe, click on bell icon and comment. Thank you. Stay tuned to next sessions.